Hello my dear friends, welcome back. I am sure you're all doing well and I'm very sure, more sure that your studies are also going on very good, not affected by the pandemic because everything depends on oneself only. So stay at home, stay safe, study. All these materials are all made for you only, so please study. Alright, so let's continue with continuity again. It's a big exercise with lots of questions. So if you have not watched the previous videos or not, please do go through those previous videos. I'll provide you the link below because the sequential study is very important, especially in calculus, and also please do go through that and come back again. We'll continue with question number 13 of exercise 5.1 continuity. So take out your book, pen, paper, textbook if you have. Let's begin. Alright, so shall we begin? 5, 4, 3, 2, 1. Hello. Question is if the function defined, is the function defined by this a continuous function? So I had already given you a separate video on algebra of continuous functions. So again, that also I'll provide you the link below. You can just go through those where we have seen so many theorems again. So is it a continuous function? Let's see. Solution. I'm just going to write a summary only. Alright, so for x greater than 1 and x less than 1. Let's say for x greater than 1, the function f of x is greater than 1, x minus 5. And for x less than 1, our function is less than 1 is x plus 5. So actually what? Both are polynomial functions. So they are continuous functions. So for greater than 1, less than 1, we know they represent polynomial functions. So from algebra of continuity, we have seen that polynomial functions represent continuous functions. So now we have to check at x equal to 1. Alright, so that's the only question mark that we have. So let's solve for x equal to 1. So now at x equal to 1, what will be my function f of 1? At x equal to 1, f of 1 would be 1 plus 5, so that would be 6. Alright, let's start with the right hand limit. Right hand limit would be limiting value of the function as x tends to greater than 1, or limiting value for a very small interval f of 1 plus h. We have been doing that. 1 plus, that means slightly greater than 1 for a very small interval, 1.001. So the intervals are very, very small. Okay, so that would be for value that is slightly greater than 1. What is the function? Greater than 1, this one. So my function is this for f of x. So x will be replaced by this. So that's going to be 1 plus h minus 5. So that would be limiting value as h tends to 0. That would be 4 plus h. So once we use the value of the limit h tends to 0, we get what? 4. So of course immediately we can see that it's not continuous, but let's just check the left hand limit also. That will limiting value of x tends to 1 minus f of x. So that would be limiting value as h tends to 0 for a very small interval that is slightly less than 1. Because our point here where we are checking is 1. So that would be slightly less than 1, that's x plus 5. So limiting value as h tends to 0, that would be 1 minus h plus 5. So that would be limiting value as h tends to 0, 6 minus h. So using the value of the limit h tends to 0, we get 6 here. So of course left hand limit corresponds to the value of the function, but not the right hand limit, as you can see. Of course, this would be minus 4, not plus 4. Sorry. this would be minus 4. So we can clearly see that the left hand limit and the right hand limit are not equal. So the function here actually what is not actually continuous at x equal to 1. So it's not a completely continuous function. So since, I'll just write in short, left hand limit is not equal to right hand limit, what shall we write? F of x is not a continuous function or not continuous at x equal to 1. Slightly greater than x, greater than 1, slightly less than 1, it is continuous, but at x equal to 1, it is not continuous. So that's what we are trying to do. Alright. So that's it. Let's move on to question number 14. So the question is, discuss the continuity of the function. F. Discuss the continuity of the function f, where the function that is given to us is 3, 4, 5. 3, 4, 5. The value of the function corresponds to this if x is greater than or equal to 0, less than 1. So definitely x is greater than or equal to 1, greater than 1, less than 3, greater than 1, less than 3, and here x is greater than or equal to 3, less than or equal to 10. So we are here to check the continuity of the given function. So some intervals are given to us. So we just have to check now whether the function is continuous, or if it is not continuous, then can you give us those points where the function will not be continuous. That's what the discussion is all about. That's why the question is, discuss the continuity. So we'll have to discuss the continuity. So is it continuous throughout? If no, then if it is not continuous at some points, can you just tell us what are those points where the function is not continuous? Likewise. Alright, because it is clearly given that for any value greater than 0 and less than 1, the function is 3. For any value greater than 1 and less than 3, the function is 4. For any value greater than 3 and less than 10, the function is 5. So these are constant functions, so definitely they are continuous. But what about at the points, at x equal to 1? Here of course it's 1. So at x equal to 1, the slightly greater than 1, slightly less than 1, is it going to be continuous? That we cannot say actually. What about 3? That's another point again. Now less than 10, so okay, our interval is like between, we have to just check the continuity between 0 and 10. That's what it says, no? Greater than 0, less than 10. So within this limit, we'll have to check whether they discuss the function is continuous or not. So let's begin. So definitely, of course, for some values like greater than 0, let's write down. I'll just write it down. Write down. If, that's not if, for x greater than 0, less than 1, our function f of x is 3, right? For x greater than 1, less than 3, our function is 4, isn't it? And for x greater than 3, less than or equal to 10, our function is 5. Of course, we'll get back to that. Some of you must be still confused. So it's actually greater than or equal to, yeah, don't worry. But now we're just doing it in general, like for greater than or less than, strictly greater and strictly less. At 3, that we will decide. We have seen that we cannot decide on that, isn't it? This 2 we are writing because that's the limits, upper and lower limits, no problem. But these values we still have to decide, because at equal to 1 we haven't checked yet, so we just can't say. We can just say for x greater than 1 and less than 1, but at x equal to 1, see, at greater than 1, less than 1, they may come to a point, but at equal to 1, we still haven't checked yet. We do not know. So that we cannot speak of. Alright, so like greater than 1, greater than 3, less than 1, less than 3. So here of course the functions are constant functions. So definitely for these values of course the function will be continuous. So for x equal to 1, this is equal to 1. I'll just continue here. Are constant functions. Are constant functions. Okay, our constant functions. So I'll just write here, I'll continue here. Our constant functions. So you can write down our constant functions. So it is continuous in this interval. So it is continuous in this interval. So we have to check the continuity at x equal to 1 and x equal to 3. At x equal to 0 we can't check because we can't go for the left hand limit. At x greater than equal to 10 we can't check because again we cannot go for right hand limit. So these are the limits within which we'll have to check or discuss the continuity. So we'll have to check I'll rub this off because you have written it down, so I'll use a textbook if needed. So we have to check now the continuity at x equal to 1 and x equal to 3. So one by one, let's just check the continuity. So let's begin at x equal to 1, f of 1. That's value of the function at x equal to 1. That's actually given to us. That is, okay, I'll have to write down the function because according to that I will be showing you also. So in short only I'll write, okay. That is 3, 4, 5. So here in brief only I'm writing x greater than or equal to 0, less than or equal to 1. X greater than 1, less than 3. X greater than or equal to 3, less than or equal to 10. That's it. Yeah. So at x equal to 1, our value of the function corresponds to 3. Isn't it? Alright. Then let's go for right hand limit. I was writing L. Better to begin with right hand limit, sorry, not right hand side. That's limiting value as x tends to right hand means slightly more than 1. We are checking at the point x equal to 1. F of x, so that will be limiting value as h tends to 0 means for a very small interval that is slightly greater than 1, that is 1 plus h. So that would be limiting value as h tends to 0, slightly greater than 1, slightly greater than 1, slightly greater than 1. Isn't it x greater than 1, slightly greater than 1. So 1.00001 is also slightly greater than 1 even if h is very, very small. So this is how much? 4. So the value of the function of course will be 4. What about the left hand limit? Left hand limit will be limiting value as x tends to like slightly less than 1. F of x, so that will be limiting value as h tends to 0, f of 1 minus h. This time it is slightly less than 1. So limiting value as h tends to 0, slightly less than 1. Now this is greater than 1. We are now going to talk of slightly less than 1. Less than 1 represents how much? 3. So now here what happens? It is 3. So what do we get here? The left hand limit and the right hand limits are not same. One corresponds to 4, one corresponds to 3. That means definitely our graphs are not going to converge at a particular point. So that means the function that was given to us, I'm rubbing down, is not continuous at x equal to what? At x equal to 1. So I'll just write, since left hand limit is not equal to right hand limit, of course it also has to be equal to f of 1. Right, but I'll just use left hand limit and right hand limit because it's already proved that it is not continuous. So our function f of x is not continuous at x is equal to 1. Got it? Let me get some chalks. Alright. So now next job is to check at x equal to 3. My dear students, please don't be lazy in your studies. You know, this online, offline studies and all can be like very, thing, because we are at the comfort of our home, so there is nobody to give us a deadline, nobody to tell us what to do, what not to do. So you will be making decisions for yourself. You're all grown-ups now, 11, 12 standard. But please see to it that you are really grown-ups, you act responsibly, and take care of studies also. Of course, you rest. Rest is very important, but at the same time, do not over-rest also again. Okay? So please make sure that you study, keep a separate time, maintain a separate routine also. So as I've already made a study video on study tips, I'll provide you the link below. If you haven't watched, you can just watch those also. That may not be the absolute, but still then you can learn something from it. So make sure that at least you devote 2-3 hours in a day separately. After that, the rest of the hours, fine, you watch movies, you play games, you do what you have to do, but stay at home, stay safe, and the rest, as well as take care of your studies also, because nobody's going to take care of it, only you will have to take care of it. All right. Now at x equal to 3, our function x equal to 3, 5. 3 plus right hand limit slightly greater than 3, so 3 plus h. So slightly greater than 3, limit x tends to 0. Slightly greater than 3, 5. So this value is 5. What about the left hand limit? Left hand limit is limiting value as x tends to 3 minus, that is slightly less than 3. So that would be limiting value as x tends to 0, f of 3 minus h. Now this time slightly less than 3, That is limiting value as x tends to 0, 4. So here also you will see that the limit is again what? Not continuous. So LH left hand limit again is not equal to RHL. So f of x is again not continuous at x equal to 3. So within the limit, within the interval given to us, what can we say? That the function is continuous within the limit, okay, everywhere, except at x equal to 1 and x equal to 3, because for strictly greater than 1, strictly less than 1, we have already seen they represent constant functions, so they are continuous. So that's why we really had to check at x equal to 1 and x equal to 3 within the given interval. So there we see that at x equal to 1 and x equal to 3, what do we have? We do get that the function is not continuous. So as within the interval, our function is definitely continuous, except at the points x equal to 1 and x equal to 3. Alright, now let's move up. Similar questions, so I would prefer you to be doing. So I'll just move on to question number 16. Similar questions, so the 15, maybe you can give it a try. If you cannot, then please do mention in the comment section below. I will definitely do it for you, but you give it a try, okay? If x is less than or equal to 1, if x is less than or equal to minus 1, here, if x what? Greater than minus 1, less than or equal to 1. So that means here, greater than 1. Okay, so here x is greater than 1. So here also what we see, the same stuff. At x strictly less than minus 1, our function is minus 2. At x strictly less than 1, greater than minus 1, our function is 2x. Of course, minus 2 represents constant function. 2x, of course, represents polynomial function. These are not very much necessary, but I'm just giving it to you so that you're not confused if there are any questions based on it now. And for x greater than 1, we see that f of x is 2. That is also a constant function. So it is continuous. Now we have to check continuity at which points now? At definitely -1 and +1. So we have to check the continuity at -1 and +1, because here it's like x within this we can see x less than 1 already discussed, greater than 1, less than 1, -1 +1 already discussed, greater than 1 already discussed. Now the only points that is left for us where we are suspicious is -1 and +1. So these are the only 2 points left for us to check. Let's check. Alright, so I'll rub this. Okay. At x equal to -1, let's begin. So f of -1, the value of the function at x equal to -1 is -2. Right hand limit, that is limiting value for x slightly greater than -1, that is -1 plus. Can you see? Or x tends to -1 plus, that means slightly greater than -1, f of x. So that should be limiting value as x tends to 0, slightly greater than -1. So -1 plus h, f of -1 plus h. So that would be limiting value as h tends to 0, -1 plus h, slightly greater than -1, that would be 2x. 2 into x, our function here variable is for the function -1 plus h. So this value will be, okay, I'll just write it down. Limit as h tends to 0, -2 plus 2h. So if you remove the limit now, h equal to 0, what do we have? We get -2. Left hand limit, limiting value as x tends to -1 minus left hand limit, that is limiting value for a very small interval for f of -1 minus h, slightly less than -1. Now that was greater than -1, now less than -1, that is limiting value as h tends to 0, -1, slightly less than -1 now, -1 minus h, slightly less than -1. How much? -2. So this value, by applying the function, what do we get? Sorry, -2. -2. So what do we have here? Unlike the previous question, -2, -2, -2. So what do we conclude? Since the left hand limit is equal to the right hand limit is equal to the value of the function at x equal to -1, what do we say? F of x is continuous at x equal to -1. So that point is done. Clear? Alright? Okay. So the next point that we have to check is at x equal to +1 now. So f of 1. What is the value of at x equal to 1? That is 2x. That is 2 into 1. That will be 2. What about right hand limit? Right hand limit will be limiting value as x tends to 1 plus, slightly greater than 1, f of x. So that will be limiting value as h tends to 0, f of 1 plus h. Now 1 plus h, slightly greater than 1. So that would be, what is the value of x for the limit slightly greater than 1, greater than, slightly greater than 1, slightly greater than 1, 2. So the value of the limit is limiting value of the function is 2. What about the left hand limit? Left hand limit, that is slightly less than 1, that is 1 minus. So I'm just doing over this, 1 minus. So slightly less than, continuous, slightly less than -1, slightly less than 1, 2x. So that will be limiting value as h tends to 0, 2x. What is the value of x here? 1 minus h. So that will be limiting value as h tends to 0, 2 minus 2h. So here also, of course, using the value of h tends to 0, what do we get? 2. So here also, what do we have? So here also we see that the value of the function at 1, 2, left hand limit, right hand limit, they are all 2. So the same conclusion again. That is, left hand limit is equal to right hand limit is equal to value of the function at 1. So f of x is, in short only I'll write just to save some time, is continuous at x equal to 1. So the function is continuous where? Everywhere. Where? Everywhere. Alright. So pause. Chalo, I'm wrapping it up. So it's not a very difficult thing. You have to get used to it. That's the only catch involved. You need to get used to it. 17. Find the relationship. Please pardon my handwriting. Find the relationship. I know it's horrible. Find the relationship between A and B so that the function f defined by f of x is equal to ax plus 1 bx plus 3 if x is less than or equal to 3, if x is greater than 3, is continuous at x equal to 3. So what's the question here? You're not supposed to check the continuity here, it's already continuous. What you're supposed to do is, with the help of that knowledge that the function is, continuous, you're supposed to find a relationship between A and B, not the values of A and B. Many do not read the question properly, okay? So please see to it that you read the question properly. So you just have to find a relationship between A and B. Got that? With the given knowledge that the function is already continuous at x equal to 3. Well, since the function is continuous at x equal to 3, what will happen? Left hand limit will be equal to right hand limit will be equal to the value of the function at x equal to 3. Alright, let's start with the left hand limit. Left hand limit, that is limiting value as x tends to 3 minus, because our point is 3, no? 3 minus, that is slightly less than 3, that is for a very small interval h tends to 0, f of 3 minus h. So what is the value of the function that they give you for values less than 3? This one, ax plus 1. That's going to be a, what is the value of x here? 3 minus h plus 1. So I'm going to directly substitute the value of h just to, so that's going to be 3a minus 0 plus 1. So what do we get? 3a plus 1. I'll just mark this as equation 1. Directly I'm doing it because it's all the same. I guess you can also understand from that. No, it's not very difficult because h tends to 0, so h equal to 0, so ah will be 0, so I'm just doing it directly. It's all the same. हो गया? अभी क्वेश्चन रिमूव करेगा हम. उसके बाद राइट हैंड लिमिट निकालेगा. राइट हैंड लिमिट इज इक्वल टू limiting value as x tends to 3 plus, that is slightly greater than 3. I hate these formalities, but उपाय नहीं है, लिखना तो पड़ेगा. 3 plus h. So that will be limiting value h tends to 0, 3 plus greater than 3, that is bx. What is x? This plus 3. So that's going to be, again here also I'm just going to use the value directly, HB, H tends to 0, that is 0. So what do we get? 3B plus 3, that is equation 2. So what the question says is you just have to find a relationship between A and B. So I don't think we will need the value of the function as x equal to 3 because we just need the relation only, but we just need that. So I've already mentioned it at the beginning, since left hand limit is equal to right hand limit. What can we have? 3a plus 1 is equal to 3b plus 3. So 3a equal to 3b plus 3 minus 1. So that's going to be 3a will be equal to 3b plus 2. In other words, a equal to 3b by 3 plus 2 by 3, 3, 3. So a can be written as b plus 2 by 3. I guess this can be the relation, isn't it? A equal to b plus 2 by 10. So a equal to b plus 2 by 3. We were just told to find a relationship between a and b using the condition. We did that. Finished. Okay, rubbing it off. Pause and write. Okay. Alright, one more. 18. For what value of lambda is the function defined by f of x is equal to lambda x square minus 2x or 4x plus 1 for x less than 0, x greater than 0, continues at x equal to 0. After that, I'm just writing it here. What about continuity? That's the question. What about continuity at x equal to 1 also? So we have two parts of the question here which we will have to define. So the first part, of course, will be similar to that previous question, that is, for what value of lambda is the function defined by this continues at x equal to 0? So fine, for what value? So we just cannot use that the function is continuous, because it's not given that the function is continuous. They're just asking you for what value is the function continuous at x equal to 0. At x equal to 0, let's find out the values. That is x equal to 0, f of 0, 0, this one. Lambda into 0 square minus 0, of course that's going to be 0. Right hand limit, that is limiting value as x tends to 0 plus, because we're checking at x equal to 0. F of x, that is for a very small interval as h tends to 0, slightly greater than 0. So that will be limiting value as h tends to 0, f of h. So this is slightly greater than 0 for x plus 1. So limiting value as h tends to 0 for x plus 1. So that's going to be just putting the value of the limit h tends to 0, 0, 1. So our value is 1. Alright. Left hand limit. Left hand limit, of course it's not continuous, we can clearly see that, but I'll just finish it up. That will be limiting value as h tends to 0, f of 0 minus h. That will be limiting value as h tends to 0, f of minus h. So slightly less than 0. That's going to be limiting value as h tends to 0, lambda into minus h square minus 2 into minus h. So that's going to be, of course, 0, 0, 0. So that's going to be lambda into 0. That's, of course, again going to be 0, because h square plus 2h, but h tends to 0, so this value is again 0, plus 0, that's again 0, into lambda, that's again 0, so this value is also 0. Now we can clearly see that here what happens here is the left hand side and the right hand limit. No, left hand limit and the right hand limit do not correspond to each other, isn't it? Right hand limit is 1, left hand limit is 0. So actually what is going to be the conclusion? There is actually no particular value at x equal to 0 for which the function can be continuous. There is no particular value because it's not continuous, because right hand limit, left hand limit are not same. So since left hand limit is not equal to the right hand limit, f of x is not continuous. F of x is not continuous at x equal to 0 for any value of lambda. For any value of lambda. Okay. So here we cannot get the value of lambda like in the other questions. Done. Rubbing it off. Chalo. Next we have to say, what about continuity at x equal to 1? We don't know, we will check at x equal to 1. So f of 1. I'm not going to write down the function because I've already written, so I'll just get it from the textbook. At x equal to 1, lambda 1 square minus 2 into 1. So that's going to be lambda 1 minus 2 minus lambda. Alright. Wait, at x equal to 1. Okay, sorry. We don't have the function for that here. So at x equal to 1. Chalo. I'll have to write down the function. I forgot about that. So that's going to be lambda into x square minus 2x for x plus 1, x less than 0, x greater than 0. Chalo, greater than 0. So you have to check the continuity at x equal to 1. At x equal to 1. So I'll have to start with the right hand limit. I just cannot go for x equal to 1 blindly. No. Right hand limit will be limiting value as x tends to 1 plus f of x, that is slightly greater than 1, that is limiting value as h tends to 0, f of 1 plus h. So that's going to be limiting value as h tends to 0. 1 plus h, that's going to be like greater than 1. Greater than 1, we don't have that 1 here, but greater than 0. So 1 is always greater than 0. So any value greater than 1 is of course greater than 0. So this will be the function. 4 into 1 plus h plus 1, because the value of function x is this one. You got that? We're checking at 1, once again I'm repeating, and checking at 1. So here 1 plus, that's greater than 1. We don't have that interval here, but since it says greater than 0, so greater than 1 is always definitely greater than 0. So the award goes to this, for x plus 1. You'll have the privilege. So in that case, okay, I'll just write h tends to 0, 4 plus 4h plus 1. So that's just like 5 plus 0, so that's 5. So that's the right hand limit. Right hand limit. Right hand limit. Got it? Alright, now let's move on to the left hand limit. I'm just going to write over this. So shall I rub it off now? Okay. Some of you might be still confused. So left hand limit. Left hand limit, that is limiting value as x tends to 1 minus f of x, that would be equal to limiting value as h tends to 0, f of 1 minus h, so that will be limiting value as h tends to 0. Now again here, less than 1. less than 1. But what is the value of h here? It's clearly, we know h is a very small interval, that is like very small. That means like 1 minus 0.00001. So definitely 1 minus 0.00001, that's going to be like 0.9999999, something like that. So 1 minus h also definitely will be greater than 0. Why? Because h is not a very big value, or it's not an integer, it's a very small interval. So if you remove, if you subtract h from 1, it's really not going to matter. It's almost approximately going to be 1 only. So definitely again it's going to be greater than 0 only. So we are going to use the same function again, that is 4 into 1 minus h plus 1. So this time I'm going to do it directly. So that will be h tends to 0, 4 minus 4h, that is 0, plus 1, that is equal to how much? 5 here also. Alright, fine. So that part is done. Now at x equal to 1, so our function here f of x, which is greater than 0, is 4x plus 1. So definitely at x equal to 1 will be 4 into 1 plus 1. That's going to be again 5. Why did I choose this function? Look carefully. Because this function clearly says x greater than 0. So whenever the value, sorry about that previous one, okay, without really focusing, I just jumped into it. It happens, I'm also human. But now, since it's also sorted out, sometimes it happens, we as humans, when we teach continuously for a very long time, concentration, focus just goes off, just like when you study, your focus goes off. So sometimes it happens, so please, I hope you will understand. Please excuse me for that. Alright, now forget it, come back. F of x is equal to, we have two values here, but what are we dealing with here? We are dealing with the point x equal to 1. So that is like definitely greater than 0. So it clearly says that for any value of the x which is going to be greater than 0, you will use this function. Now 1 is definitely greater than 0. So we're going to use this function 4x plus 1. So f of 1 will be 4 into 1 plus 1. That's going to be 5. So here, since the left hand limit is equal to the right hand limit is equal to the value of the function f of 1, f of x is continuous at x equal to 1. Alright, so I guess that should be enough for today. Please go through it. If you have any problems, please do let me know in the comment section below. Definitely I will try to fix it. Alright, so that should be enough for today. Please practice this 2-3 times, revise this, do it again and again till you really get the concept. Okay, so that's it folks for today. We'll wind up here. I'll see you in the next video with the next set of questions. Bye bye, take care, stay safe.